Okay, so we have here, I just copied this from your textbook. So this is just a list of properties of limits that you guys have there. There's also a warm-up problem that we didn't do that one. I wanted to do something different. So, because you guys don't have the 89 calculators yet. So, if we have a limit of f of x that equals L and a limit of g of x that equals M, we have several different rules for limits. So the sum rule tells us if you have f of x plus g of x, and the limit of f is L and the limit of g is M, then your answer is just L plus M. Difference rule is similar, just L minus M. A constant multiple rule, if you have a limit of some constant here, like 5 times f of x, then it's just going to be 5 times that value L. The product rule tells us if you're finding the limit of f times the limit of g, you just do those separately, you'll get L times M. Quotient rule, similar. Division, here you do have this exception here that M cannot equal 0, because if M equals 0, then of course it would be undefined and you couldn't get that answer. The power rule, if you have a function raised to a power, then it's just your answer raised to that power. And your root rule is similar. You really could use that for the power rule. If you have a root, it's just the root of your answer. So basically we're going to see that we can break limits down into like separate pieces is what we're going to see here. So let's look at some of the things that you're going to be asked to do. So if you have two functions, f and g, they've given you that the limit as x approaches 2 of f of x is 5, the limit as x approaches 2 of g of x is 6, limit as x approaches 4 of f of x is negative 1, and limit as x approaches 4 of g of x equals 9. Now, I'm only going to do this one time where I write it out the long way, because I would never do that if I was working out these problems. But I want you to see like how those properties translate. So for this, the properties translate in that, let me zoom in a little bit more so I got some room. In that, I can take the limit of the top and bottom of this separately. I also, this coefficient right here, I can kind of pull it out. So it would be 2 times the limit as x approaches 2 of f of x divided by the limit as x approaches 2 of g of x. All right. And then if we look up here, we know that the limit as x approaches 2 of f of x equals 5. And we know that the limit as x approaches 2 of g of x is what we have right here. That equals 6. So essentially, we are just plugging those values in. So 2 times 5 over 6, which is going to give us 10 over 6, which we could reduce to 5/3 there. Now, I would never write that middle step there if I were doing these problems. I'm just trying to show you why they gave you that long list of properties. So if we have something like the limit as x approaches 2 of g of x plus 3 f of x, I know the limit as x approaches 2 of g of x is 6. 3 is just a coefficient, and f of x, that limit as x approaches 2 was 5. So make sure you multiply first. So you got 6 plus 15, which is going to give you 21 for that one. Okay. 3 is the limit as x approaches 4, and you've got f of x minus 2 squared. So I think the constant rule I'm doing next, but this is just going to be a negative 2. So we'll have the limit as x approaches 4 of f of x is over here. It equals negative 1. So we will have negative 1 minus 2 squared, which would be negative 3 squared, which would equal 9. And for the last one, we've got our g of x, and the limit is approaching 4, so we're going to use this 9. So we would just have square root of 9 plus 4, which is 3 plus 4, which is 7. It turns out to be almost just like you're plugging in those values for your F's and G's, right? Okay, questions? All right. Limit of composite functions is different and a little bit more complicated, particularly when they give us some graphs. It's going to be get a little crazy on some of the graphs. So, F and G are functions with the following limits. We got limit of G of X equals capital L, and the limit as X approaches capital L of F of X equals F of L. So, if I'm trying to do F of G right here, I would do the limit as X approaches C of G of X first. Just like whenever you're evaluating something, you would do the inside part of that first. It's like your parentheses there. So you're taking the limit of the inside first, which is capital L, which will give you whatever F of capital L would be. And notice right here they told you the limit as X approaches capital L of F of X would equal capital L. So they really could have even added in, like this step right here, they could have put it right there as well. So let's look at what that looks like in practice, because all that theory seems maybe a little confusing. All right, so we have F of X equals 2X minus 1, and G of X equals 1 over X plus 2. We are supposed to find the limit as X approaches 3 of F of G of X. And I'm probably getting, let's see. Let me see. I'm trying to think of how I taught this because I'm getting a little ahead of myself. Did I use Desmos and use the graph? Or did I? Surely I used the graph for this. I think I used the graph. It can be done a couple ways. But I haven't shown you the other way comes up in the next note. So I think I used Desmos for this. So, if I've got my two functions, F of X equals 2X minus 1, and then I've got G of X equals 1 over X plus 2. Okay? So we can look at these one at a time if we need to by getting rid of that. Let me make this where it's darker. All right, so if we do this first problem, we would be doing, really what we're doing is we've got to do the limit as X approaches 3 of G of X first. We've got to do that part first, and then we're going to plug that into the other. So the limit as X approaches 3 of G of X, so if we're looking at G of X, I can even put in X equals 3 here so we can see it on our graph. There's our line. As X approaches 3, what value are we approaching? Here, 2.3 repeating, right? We can see there's not even a hole in the graph right there. It's just a solid line. So that limit is 2.3 repeating. So then what we find ourselves doing here is doing the limit as X approaches 2.3 repeating of F of X. Okay, so if I look at F of X now, and I want to look at 2.3 repeating, right? At 2.3 repeating, I've got 3.667. So 3.6 repeating for that. So for these, inside first, you're doing the limit of your inside first, and then whatever you get for that answer becomes what you're approaching. Okay. Now, here's something else I need to show you, because this is weird. On some problems, it does not make a difference at all. On this problem, it would not make a difference at all. If I look at that first thing that I did, the x approaches 3. Okay. When I do that limit, okay, as I approach 3, right, are my values right here higher or lower than 3? My y values. They're higher. Okay, as I approach 3 from the left, are my values higher or lower than 3? Right, y values higher or lower than, I'm sorry, it should be 2.3 repeating, I'm saying. So like, are my y values below that point or above? They're below, right? I'm approaching from the top over here, from the bottom over here. Okay? So what that means is that I should have been doing just the limit from both sides on this. I don't think we see it on this problem, but there's going to be a difference if you don't approach from both sides. If we have, we'll see one here in a minute. If we approach from the top on both of these, it means we're going to have to approach from the right there. So keep that in mind. It's not going to affect this problem, but it will affect some of the ones coming up. All right. So let's do this the other way around, though. This time we're looking at 0, and we're doing g of f of x. So let me change that to a 0 right there. Which function do I need to take the limit of first? F of x. So let me get rid of f of x, g of x. Let's look at f of x. So the first thing I'm doing is I'm taking this limit of the inside. So if I take the limit of the inside, the limit as x approaches 0 of f of x is going to be, what would we get right here? -1. That's our y value. All right, it's just a solid line. You have a limit everywhere. It's not complicated. So then that means I'm taking what I have here, and I'm going to use it for my limit as x approaches -1 of g of x. Now, notice right here, I'm going to point this out again. This approaches from top and bottom. So top and bottom is going to translate to left and right here. So x approaches -1 of g of x. So let's go back to g of x, and this time we're approaching -1. And here, as x approaches -1 on g of x, our y coordinate is 1. So again, we're doing the limit of the inside first, and then whatever we get as our answer becomes where we're approaching on the next part. Does that make sense? Okay, now sometimes you run into trouble with this on problems like number 3. Because if I'm doing x approaches 0 of g of x, what is the first thing I have to do is that limit of, as x approaches 0 of f of x, limit as x approaches 0 of, I'm sorry, g of x, I'm saying now, g of x. Okay, what is our limit as x approaches 0 of g of x? Does not exist, because on the left side we would go to -infinity, on the right side we would go to +infinity. So that is a does not exist. So since I'm getting does not exist here, the whole thing is going to be does not exist. That's really not mathematically correct for me to put this equals right there. So if you get a does not exist on that first step, you're going to get a does not exist for the whole thing. Yes? Right now, just with the calculator is fine. And I'll have to look and see if I put this particular one. I think the ones I put on the quiz had graphs with them. I don't think they were ones where you had to type it in. We are going to learn how to do these by hand shortly. So once we learn how to do them by hand, you can. But for this quiz, you won't. So I think they have graphs with them. I'll check. If they didn't, I'll put Desmos with it. Although, certainly on the actual exam, you'd either have to use your calculator or they'd give you a graph. Usually they would give you a graph on the problems like this. Yes. On the first step, yes, unless they were to put a plus or a minus there. On the second step, on that second part, it sometimes is not from both sides. And we're going to see an example where that happens. Because I'm going to tell you, it took me a couple years maybe, or teaching it a couple times to even get my head kind of wrapped around it. So hopefully I understand it better now and I can explain it to you guys better now, but it's a little confusing. It's really the only confusing part of these notes. Otherwise, they're fairly straightforward, I think. Let's look at this, okay? Functions f and h are graphs. So we've got f here, we've got h. They're asking us to find the limit as x approaches 0 of f of h. So I think this is probably what you're more likely to see on the quiz is ones that actually have the graphs for you, so you don't have to graph it with Desmos. So what we would do first is we would do the limit of the inside. So the first thing we're looking at is the limit as x approaches 0 of h of x. Okay, so here's where things get weird. Okay, this one's weird. All right, what is our limit as x approaches 0 for h of x? It's -1. All right, now let's think ahead. If we go over here to -1 on f, what's it look like? Looks like it does not exist. It's not the answer. There is an answer for this. Well, technically, I guess it does not exist, but what do you think? It's going to be positive infinity, which is confusing to me, but let me see if I can explain it to you. Okay, so notice before I was saying we kind of want to see whether we're approaching this -1 from the top or the bottom or both sides, right? You need to think up and down vertically here. So as we approach here, that point, we approach from the top, right? So all of our values that are our y values here are becoming our x values over here, right? So this is a y value for h, but when we do the f portion, it's going to be our x values. And those values are not approaching from above and below -1, right? They're both coming from above -1 if we're thinking about our y values, right? So since this is from above, that translates to from the right on this problem. So we're doing the limit as x approaches -1 from the right of f of x. And if we only look at the right-hand side of this graph, we approach positive infinity here. So that is our final answer there. That -1 goes here.
So if it's pointing upwards, like both of them would be like that, and it does not exist.
Yes, so like for this problem, if they had both came from the bottom, then we would say it would be -infinity because we'd be looking at the left-hand side of this graph. And if it had done like this, if my graph, instead of looking like it does, had crossed right there, and maybe we didn't have this side, right? One is above, one's below, then that would mean both sides, and we would have to look at the limit from both sides here, which would be it does not exist. Okay, have I blown your mind? Or maybe I explained it better than, it took me a while on these. All right, let's do another one. Okay, here's another one. f of h of x. So we got f here, we got h here. So what we would do is we got to do limit of the inside first. So limit as x approaches 0 of h of x. Okay? And so whenever we look at this, Abby, if we do the limit as x approaches 0 for h of x, what will we get there? 0. We get 0. Okay? But we got to stop on these and think about, did we approach from above, from below, or did we go like different on each side? So over here on this side, we're above. And over here on this side, we're also above. So we're approaching only from above, which when we go to the next step and translate this to our x right here, that means we're approaching from the right. Okay? It doesn't make a difference on this problem. You could mess this one up and it wouldn't matter. Because whenever we look at f of x, we don't have a whole or asymptote or anything here. Our limit as x approaches 0 from the right would be the same from the left, so you would get 1 even if you messed it up, even if you only looked at the whole picture, right? So sometimes it's not going to mess you up to forget about thinking about whether it's above or below. But what we would be looking at here is just this right side of the graph. Oh, it should be -1, thank you. That's what the puzzle looks for. Yes, -1. Okay, questions? All right, here's another one. And this one only gives us one graph. This is asking us to find f of x. So we're composing a function with itself. We're doing this function twice. So we would have to do the inside first, right? So we would be doing limit as x approaches -4 of f of x. And so, Reagan, whenever we do that, limit as x approaches -4 of f of x, what would we get? -1. Okay? Now, it's going to matter on this one, whether or not you pay attention to whether it's approaching from above or below. So for this one, on the left-hand side, are we above or below? Below. On the right-hand side, are we above or below? Below. All right, so that means since we're coming from the bottom side on both sides here, whenever we do this, we're going to do limit as x approaches -1. So this number right here is going right here. We're doing f of x again because we're composing it with itself, f of x, right? Limit as x approaches -1 of f of x, but because both of these came from below, that means we need to put a negative over here after this. We're doing this from the left, not from the right, which makes a big difference on this problem because at -1 right here, I've got a jump in the graph. And I'm going to get, if I do it from both sides, I'm going to get does not exist. If I do the wrong side, I'll get a different number, right? On the last problem, you could have gotten it right, even if you didn't think of it. But on this one, it matters. So limit as x approaches -1 from the left, what do we get for that one, Avery? -5. Perfect. And that is your final answer, -5. Okay, questions? Okay, so we got two things that we are going to do. This work is from your textbook. It's going to give you practice with the beginning stuff that we did, where it gives you pieces of a function and you're having to plug that in for different operations, not functions, with limits. And then, I'm going to try to go over this before we go because we have about almost 20 minutes, and it should be pretty quick for that. Then your other assignment for tonight is from Delta Math. And it's going to be properties of limits. And it is going to have a lot of those graphs where you're doing the composition. Our book doesn't have a lot of that. So it's going to be from Delta Math, and you're going to complete it as well. So this we're going to try to go over before you guys leave. If you finish it, though, you can go ahead and go do the Delta Math as well.